Hello and welcome to space. Now it's amazing to think that everything we can see around us, from planet Earth to distant galaxies, represents just 5% of the universe. The rest is either dark energy or dark matter. We're here at CERN to try to understand more. So what do we know and what do we not know about dark energy and dark matter? Let's find out. The simple answer is that we don't know much about dark matter and even less about dark energy, but all that could change quite soon. This is CERN, home to the world's foremost particle accelerator, the Large Hadron Collider. 3 years ago, it spotted the Higgs Boson. This year, it's back and better than ever.
We hope that as soon as the machine switch on, we might have discovery even in the first days, if not in the first weeks.
Take your time and look around. So many things to see.
The reason for that optimism is that the LHC is now going to be run at full power for the first time. And at full power, it might identify dark matter.
And a place to be. And a place to be.
The fact that the LHC is increasing its energy by almost a factor of 2 gives us all sorts of possibilities for discovering dark matter particles. We think that they may weigh something like 1,000 times the mass of a proton, or if you prefer, about 10 times the mass of the Higgs boson, no, plus or minus. And the LHC this year should, for the first time, enable us to actually produce those particles.
Such a discovery would have cosmic implications because everything, planets, stars and galaxies, is under the influence of dark matter and dark energy. And the breakthroughs won't just come from the LHC either. ESA is building a new space telescope called Euclid, which will observe the universe on the grandest scales.
I'm working on Euclid. That is a mission to map the universe and to explore the universe, to see dark energy and also to see the dark matter content of the universe. And for that we built a highly precise telescope.
Euclid will watch how the gravity of dark matter acts on galaxies and how dark energy is pushing the expansion of our universe, and it'll do so by taking super sharp images.
When we look at the sky and take a picture, we stop everything. We stop the reaction wheels, and the only way to correct for possible drifts of the satellite is doing it with cold gas, because cold gas gives no disturbances to the image, the sharp image we want to achieve.
Space telescopes and particle accelerators are the tools that physicists and cosmologists use to study dark energy and dark matter. And what they found is extraordinary. All normal matter makes up just 5% of the total universe. Just listen to this.
We now know that around 68% of the universe is made up of dark energy, a mysterious component which is responsible for the accelerating rate of the expansion of the universe. Then we have measured the profusion of dark matter in the universe to around 27%. So 27% of the universe is constituted of dark matter, which is responsible for the movement of the stars around galaxies. And then finally, around 5% of the universe is made up of ordinary matter.
What's more, the proportion of dark energy is increasing.
The interesting thing is we get more and more dark energy. Why? Because our universe is expanding. And with our expanding universe, we get more dark energy in our universe. Now, the ordinary matter, so dark matter and normal matter, is not expanding, it's diluting. So the fraction of dark energy compared to normal matter is increasing in time. When the universe expands more and more, we get more volume of our universe, we get more space, and we get more dark energy.
Dark matter and dark energy are at the root of many cosmic conundrums, but they shouldn't be confused with each other, and they're not related as far as we know.
There have been models proposed in which there is a unification between dark energy and dark matter. My opinion is that with our current level of understanding, wanting to create a link between the two creates more problems than it resolves.
However, we're making steady progress. Scientists are reasonably sure that dark matter is some kind of mysterious particle, and they'll identify it sooner rather than later.
My hope is that 10 years from now, we're going to look back on the previous decade and we're going to be saying, well, this is the decade where we finally nailed dark matter. Now, this is going to involve collaboration between particle physicists and cosmologists.
The LHC will soon be cooled down, powered up, and begin smashing protons into each other at light speed, creating new particles in the process.
We need to find something. We know that something is there, and we don't know exactly what it is. We know the question. We have many questions to answer, and we are pretty sure that the LHC can answer some of them. We hope that it could answer all of them. It is not clear.
Below the Alps and up in space, some amazing machines will be working to shed light on dark matter, dark energy, and the universe as a whole.